Solid principles. So SOLID is actually an acronym of acronyms. So the S stands for Single Responsibility Principle, O stands for Open Close Principle, L stands for the Liskov Substitution Principle, I stands for Interface Segregation, and D stands for Dependency Injection. Dependency Inversion, actually, not injection. Alright. Alright, I'm sorry about that. So we're gonna talk about the SOLID principle. SOLID is an acronym of acronym SOLID. S stands for Single Responsibility Principle, Open Close Principle, Liskov Substitution Principle, and the Interface Segregation and Dependency Inversion Principles. What So single responsibility actually means that one class should have only one reason to change. So one class should have only one reason to change. What what it actually means is, as we are as as we are building application, say suppose for a bank, uh, we will have to identify those classes in such a way that one class is doing only one activity. So account should only do account related activities, statement should only do statement related activities, probably transaction should only do transactions. Now, figuring out what is single responsibility is one of the most difficult tasks that you're going to face in object-oriented programming. Uh, no matter what you do, there will always be an overlap that you find in between functionality. Like account is based on statements, so a statement is supposed to have some intuitive knowledge of transactions and account. But the way you should one quick pro tip that I can give you is, uh, a class should be for an individual stakeholder. So a stakeholder is somebody who is going to get affected if that thing gets modified, and probably this could be, say, an employee of the company who is opening up bank accounts, right? Transaction is somebody from the, say, the bank balance and the one who manages the funds inside a bank, right? They would want to know what kind of transactions are happening, right? Each person, each entity is going to be somebody else, and they are the ones who are going to give requirements. So if not bank, then probably in an IT company, you're going to have HR, you're going to have project managers, and you're going to have executives, right? If And they're going to be, say, finance officers. The finance officer is going to release salary for the people, and HR is going to manage those people. Now, when HR gives a requirement, you're going to have to come add additional code, probably modify some existing code. And the way you draw a boundary around this thing is, it should be such that the HR component is not getting any form of overlap with the finance components, right? Because if a change of HR is going to affect the finance officer, it is going to they're not going to be happy about it, and it's going to cause a lot of confusion from the software perspective. And if we honor the single responsibility principle, this thing will be kind of taken care of. The next principle is the open close principle, and it says that an application should be open for extension and closed for modification. Right now, there are four keywords here. One is open, second is close, third is extension, and fourth is modification. Extension is giving your application an ability to support new functionalities. So an extension would be that we were doing console.writeLine all along, and it was printing output in the text format on the screen for us. A good extension is going to be, say, putting something on Twitter, right? And then I'm going to try to draw a bird here, right? This tweet on the internet should be posted instead of the console.write line. So this is an extension that instead of writing on the console, we are writing somewhere on the internet. Modification is that people said, we want your name and address for opening up your bank account. But then somebody came and said that, you know what, the name and address is not enough. We want some form of government ID as well, right? If you if you change the policy of working, how you operated in the past and how you are going to operate now, this is going to be modification. So as we are building application, we are pro this, we are pro extension. We can change the way, we can accommodate new ways of working, and we are closed for modification. We are not going to let you add different type of policy. And okay, let me change that statement. We are, I don't want to say that we are not going to let you change. When you do this, this is going to be a breaking change. And this change is going to be extremely long. It will require testing, it will require probably rewiring, creating new classes, new interfaces, the function definition, the function parameter list, they are going to get modified. So when somebody comes and tells you that, hey, I want to modify an application, or I have a change in requirement, you should always evaluate it according to the open closed principle, right? We are open for extension, closed for modification. If you apply the OCP rules, that if they are asking for an extension or they are asking for a modification, and you should give estimate or the new code based on these two evaluations. Right? Extensions are easier if you have devised your abstractions, the interfaces and abstract classes the right way. Extension is going to be extremely straightforward. All right. The next in line is the list cost substitution principle. So this principle says that there are three types. There is a parent type P, there is a child type C1 and C2. So list cost substitution says that if your application is already working with C1, it should work with C2 seamlessly. You should be able to substitute child of the same parent with one another without the application getting affected. Right? The formal definition is very difficult, that there is a type P, and there exists a type P of some specific this thing, and there exists a type C such that it is derived from type P. Then any type who is like C2, which is derived from P, should be replaceable. The C1 and C2 should be replaceable. The formal definition is very tricky, but in English it means that two children of the same parent, they should be replaceable. Right? We're going to see an example of that. The the next in line is the interface segregation principle. And for this, I'm going to give you an example of a house. Inside the house, we are getting electricity from these electricity boards, and we are also getting water from these water tankers, right? But then the outlet that we have in our house is a tap, and then what we have for electricity is a socket with multiple holes in it, right? The interface segregation principle says that when you are implementing an application, you would want to create separate interfaces for separate functionalities, right? So interface segregation is like single responsibility of interfaces. How your application is going to consume the producers, it highly depends on the functionality that you want. If you want water, you will implement the iWater implementation, or you will consume the iWater implementation. If you need electricity, you're going to consume the iElectricity interface. And in these interfaces, they can have their own providers. But then you should not find a class or an interface that says get water and get electricity together. Never shy away from creating new separate files. Alright, separate these two out, and it is okay to have multiple interfaces, and they should be logically disconnected. Right? It is just like designing your house where you would separate out all the connections. Probably you would want an internet connection, right? Create a separate interface for this. You don't want to have an overlap between different type of interfaces. If you put different interfaces together where they don't belong, it is called a fat interface or a god interface. We don't need that. You shouldn't do that. Okay. And the last principle is dependency inversion principle. And the dependency inversion principle is once again very similar to what we saw here, that instead of depending on concrete implementation, we would want to depend on interfaces. And then for this, there are multiple frameworks that are available. We are going to use those frameworks from um, by adding libraries or by using the system implementation. So for this example, we are going to start with a very simple code, and this time I'm going to write a .NET Core application. I'm going to create a new project. This time I'm not going to create a blank solution. I am okay with console application. This is .NET Core type. I'm going to call it solid demo, and then probably I can call it console app here like this. And for having a different solution name, I can just delete this part. Right, I'm going to choose .NET 5 in the create button, and we're going to see a simple hello world template project from .NET Core. Right. Now if I hit Control F5, it is going to launch the application. We're going to see hello world on screen. Right. Hello world, no surprises. I'm going to close out of this, and we're going to analyze this application for a short time. Now if we apply the solid principle to this, you will eventually realize that it is violating all five principles. It is not doing single responsibility. It has at least two responsibilities. The first responsibility is writing on the screen, and the second is the message, where the message is coming from. So it has at least two responsibilities. We are going to remove that. Uh, it is excuse me. It is also violating the open close principle, in that it is not open for extension. This console.writeLine statement is only going to write to the console. If you want to post something on Twitter or Facebook or any other social media platform, or probably if you want to just save it to the hard disk, or if you want to print it on a printer, this line is not going to let you make that switch very easily. So the open close principle is also violated. The third principle is the risk of substitution. There are no types here, so it is difficult to see. But then console is one type, and we would want to have another type like printer.writeLine or probably hard disk.writeLine, and it should give us that option of saving those things. It is not possible because we don't have any inheritance hierarchy at the moment, but we are going to change that very soon. The third is it does not depend on interfaces. An application should be coded against abstraction and not completion. And the way we see it, we are seeing a class name here. And this should be like a first red flag that we do not write code against concrete classes. We write code only against interfaces and abstractions. This is not an abstraction, this is concretion. And the last principle is dependency inversion principle. The dependencies, they are not inverted. The code is very much dependent on these concrete classes and functions. It has like very intuitive knowledge of which class to instantiate and which function to call. We want to take away that ability from this code. So let's start with the single responsibility principle, and I'm going to divide this console.writeLine and this message here into two separate classes. So let's go ahead and add those classes. I'm going to hit Control Shift Alt and C, and I'm going to say message reader. Let's fix that first. I'm going to change this to public. I'm going to add a public function called string. I'm going to call it read message. Now the hello world hard-coded string that we had there, I'm going to move it over here inside with a return statement. So I'm going to say hello world. Right? Now I can create an instance of this and call this function inside the main function. So I'm going to declare, this time I'm not going to use the var keyword because there's something that is coming in the next part. I'm going to call it new message reader. And now instead of this hello world here, I'm going to say reader dot read message. If I run the program, let me show it to you once. Our output has not changed at all. It is the same output. So we know that things are still working. Now we're going to take away this console.writeLine statement as well. This time I'm going to be a little quick. I'm going to hit Shift Alt and C. I'm going to see message writer. I'm going to go to, let's change this to public and add another public function which is going to write the message for us. And then to write a message, we'll have to receive it from the outside. And then over here, I'm going to write the message. And let's make that change in the main function as well. I'm going to say message writer, writer assigned to a new message writer. And instead of console.writeLine, I'm going to say writer.write message. If I run it again, the output is still the same, so we are good. Right? Nothing is broken at the moment. So we have partially done single responsibility principle. The reader is responsible for reading, the writer is responsible for writing. Make sense? But the program function is still kind of violating the single responsibility principle. It knows too much about object creation, and it knows too much about how these objects are connected and which function is supposed to be called first, which function is supposed to be called second, and the relationship between them. I want to give away this responsibility to something else. And the way I'm going to do that is I'm going to add another class, and we have seen that multiple times in our last session, where we add an application class. I'm going to call it app, and once again we're going to call a simple run function, public void run. And over here I'm going to do the rest of the logic that I was doing in the main function. So I'm going to take the reader and writer, I'm going to make it part of the app class like this, and because they are private members, I'm going to put an underscore over here. Make sense? And now I'm going to define a constructor, and the constructor will take the reader, constructor will take the writer as well. Just delete these underscores, and over here I'm going to say reader is assigned to reader and writer is assigned to writer. And then the same line that we had in the main function, writer.write message is going to read from reader.read message. Make sense? And now that we are doing this, the app function has a single responsibility. It only knows in which order we would want to call the read and the write message functions. Right? It doesn't create these objects. It knows that somebody is going to give me the reader and writer, and I am just going to have to pair them up. I'm just going to have to link these two function calls, and this is the main algorithm of your application. I'm going to come back to the main function. Now that we have this third member identified, I'm going to say app assigned to new app, and this new app is going to take the reader and writer object. Right? And now I can finally get rid of this line. And now it is going to do app.run. If I run it, we are still seeing hello world on the screen. Make sense? So what we have essentially done is we have fixed single responsibility, right? The main function has only one responsibility of creating objects and starting up the application. The main function is not doing anything else, right? So this is the single responsibility principle. The app function has a single responsibility of running these functions in the order in which they are intended. The algorithm is part of the application. The reader function has single responsibility of reading the message. The writer function has single responsibility of writing the message. Right? So these three functions, they look good, but the program function is still violating a couple of principles. Single responsibility is fine. It is not open for extension, and it is not doing this cross substitution as well. Interfaces are not present and dependencies are not yet inverted. Right? So we're going to work on that now. To understand open close principle, we will have to change our reader or writer. So let's go ahead and create a new writer, Shift Alt and C, and this time I want to post my tweet on, say, Facebook. So I'm going to say Facebook message writer, hit enter, and over here I'm going to add a similar looking function which is public void, and I'm going to call a write message and receive a message in the string format here. Now I can write some complex code which is going to connect to Facebook. Right? Facebook has APIs. You register the app, you integrate the client ID over here, and you will be able to connect to Facebook through your program. But for this demo, we're just going to say posting on FB, and the message itself we are going to put over here. And to use it this way, we'll have to put the $sign. Okay, so posting on FB and then the message. Let's go ahead and change the reader as well. I'm going to hit Control Shift Alt Shift and C, and I'm going to say Twitter message reader. Hit enter. Let's change this to public, and let's add the reader function. So we had the reader in the console reader, the message reader. We're going to keep the name same. We're going to call it message read message, and over here, instead of returning hello world, let's return hashtag hello world. Make sense? So the message reader was returning hello world. The Twitter message reader is returning hashtag hello world. The function definition, they are exactly the same. Now if I go to the main program, I can switch this reader from message reader to Twitter message reader, and it's going to complain. And had I had the var keyword here, it would have worked the first time, and I did not want that. I wanted you to realize that var keyword assumes the type on the right side. We don't want that. So you're going to have to change the way you are creating object. Now now multiple things are breaking. The app function is saying that, hey, I was expecting a message reader, but then you are passing me something else. You're passing me a Twitter reader, and there is no common connection. To derive that common connection, we have multiple options. The option that we are going to take is we are going to create an interface right from this class. So I'm going to click on this little screwdriver, which is the refactoring option, and I'm going to click on extract interface. Alright, you can extract the base class as well, but then I'm going to extract interface. It has added the letter I here in capital, which is standard for interfaces, and it is saying that I'm going to create a new file, iMessageReader, and then the only public method that you have is read message. So I'm going to select that, and I'm going to hit OK. Notice two things on screen. One thing is going to change here. The second thing is going to change in this part. Right? Did you notice that? That add the colon sign, and we are extending an interface iMessageReader. And if I hit F12 and go to the definition, it is going to jump to this file here, iMessageReader. So this was the second change that got added through Visual Studio. It created a file for us, a public interface with the public method as the string message. Now what I'm going to do is I'm going to copy this iMessageReader, and I'm going to apply this manually to the Twitter message reader. So now there are two implementation of iMessageReader. One is the plain message reader, and the second is the Twitter message reader. If I make this change in the app class, instead of message reader, if I replace it with iMessageReader, and this initialization here, this constructor here with iMessageReader, right, my application kind of is almost fixed. And I'm going to change this class name from a concrete class name to an abstraction, right? Golden rule. the left hand side should generally be an abstract class, right? Should be something abstract, an abstract class or an abstract or an interface, right? Some form of abstraction. Now with this, if I run the application, we are reading from Twitter. It is saying hash hello world, but it is not saying posting on FB hash hello world, because we are still connected to the console.writer, right? Let's go ahead and repeat the same change for console writer as well. We're going to come to the message writer class, click on the class name, select the screwdriver, select extract interface. The interface name is going to be iMessageWriter, and the interface function is going to be write message in a new file. So the new file is added over here, iMessageWriter, and this class is extending the iMessageWriter. I'm going to copy this, apply it to Facebook Message Writer as well, like so, and in the program I'm going to change the left hand side with iMessageWriter. The app is kind of broken now. Let's go ahead and change that as well. I just have to put the I keyword and the I keyword over here, like this. Makes sense? Now I can replace this message writer with Facebook Message Writer. And now if I run this application, it is saying posting on Facebook, hashtag hello world, right? So this has come from the Twitter implementation, and this has come from the Facebook implementation. And all these implementations, they are independent of each other. This particular class does not know anything about where the message is coming from. Alright, Twitter message reader is independent of everything else, like these readers and writers, in fact the consumers of it as well. So we have kind of applied the Liskov substitution as well. The Liskov substitution says that the derived type, Twitter message reader and the simple message reader, they can be replaced, interchanged with each other as long as they are derived from the same type. I don't like using the word derived when it comes to interfaces, but then they both are coming from the same abstraction. They're both coming from the same interface, and that's why they are interchangeable, right? So the same discussion applies to the writer as well, that I can replace Facebook writer with the simple writer because they are both coming from the same parent type, right? And then the app class, we don't have to have an interface for the app class because it is an abstraction of its own. So there are three types of abstraction that you can have. You can have a class, you can have an abstract class, and you can have an interface. So we don't need an interface for the app class. So all main function is doing now, it is creating the objects that are required for running the application, and it is triggering the application run. So this kind of code, the general term is called bootstrap. So main is responsible only for bootstrapping, right? And all the other functions, they are doing some form of simple, um, they are doing some form of single responsibility principle, and the inheritance hierarchy and other things, they are supporting the open close principle and Liskov substitution principle. And because we have separate interfaces, one for writing and one for reading, we are doing interface segregation principle as well. There is no stopping from this thing. Public interface I messaging app, something like this, and then put string read message and void write message that takes a string message. I can create a class like this, but then the thing is, if I want to create a messaging app, if I inherit from iMessaging app, or I'm so sorry, if I extend the iMessage app, right, the class will have to implement both the functionalities. It is like putting the electricity socket and the water outlet together. You don't want that. You want to have some form of segregation where readers are different and writers are different. And if you want to have a single implementation, you you can replace this line with something very equivalent. And I'm going to say I I'm going to say I message reader, comma I message writer. Right? If you want to read and write from say Facebook or Twitter, you can do this. I mean, this is fine, but then you should still have the reader and writer interfaces separate. And this is the fourth principle, the interface segregation principle. You don't want to create fat interfaces. You want to create interfaces that are just related to that functionality, because it is definitely going to give you that extra level of flexibility that you want in your applications. Make sense? So with that, let's jump to the last principle, which is dependency inversion principle. And that is the most complex of all. And I'm going to have to use a lot of .NET Core features. So pay very close attention. In .NET Core, there is something called as service collection. So I'm just going to come here and type service collection. Okay, before that, let me make a case. Uh, the way you know that you are violating the dependency inversion principle is you're going to see a lot of new keyword. And I remember from day 1 or day 2 of the C# class, I've told you that the new keyword in front of your custom classes, something that is present in your solution, is highly discouraged. You should never have the new keyword in front of your own classes. Right? It's okay to have new string like this, because string is not something that you are creating, right? But it is definitely not okay to put new keyword in front of the classes that you have written. So we are going to take away this new keyword. At the end of the exercise, this new keyword will be gone. The way it is done is there's something called as service collection in .NET Core. I'm going to hit Control dot, and when you type a class name that exists in some library somewhere in that collection, and it is for which you're not added reference. Right. So this is getting the wrong copy of it. I'm going to add a package using NuGet Package Manager. Now, up until now, we had been using multiple packages from the framework itself, and we have already seen this. Because we are only dealing with console, we were using system, but then because console is sitting somewhere deep inside these concrete classes, this is kind of lightened out. We can get rid of this, and this application is not dependent on any dependency, any DLL from the outside. If you want to add more DLLs, which is not part of this particular collection here, there is a package manager called NuGet. Now with NuGet, you can see manage NuGet packages and click on the browse part, and over here I have to search for Microsoft.extensions.dependency injection. Notice that this is the principle that we are working on, the dependency inversion principle, and Microsoft has a package for it. If you don't understand this concept for now, that is alright too. But I'm going to click on install. It is going to add an assembly to my code, and then notice that there's this third folder that got created under dependencies. That's called packages. If I click on it, I see Microsoft.extension.dependency injection, which is the package that I have installed. I'm going to close out of this. I'm going to go to the first line and type using Microsoft.extensions.dependency injection, and I'm going to hit a semicolon. Now, when I come and type service collection, notice that the IntelliSense is already suggesting it to me. I'm going to hit tab and create the object called services. With this, I'm going to use a new keyword, and now the new keyword here is fine because I have not written this service collection class. Right? So new keyword in front of a class that you've not written is fine. I'm going to do that, and there's a special syntax from generics that I'm going to use. I'm going to call dot add scoped variable, and over here it is saying that there is a T service and T implementation. Now if you look at these lines, I message reader is a service and Twitter message reader is the implementation, right? And that is the terminology that we had been using all along. We were saying that we are implementing an interface in an abstract class, right? So I'm going to use the add scoped like 3 times. I'm going to do the same for message writer as well, and I can do it for app, but then because app does not have an interface, I don't have to pass that second generic parameter. Now with this, I can get rid of this particular line. Let me go ahead and put this code back. I'm just going to comment this out so that you can later on we can later on refer to it. Now I said that we are not going to use new keyword in front of our custom classes. We're going to depend on something called as service collection. So we have informed the service collection that when somebody comes and requests for an object of message reader, give it this particular object. For writer, give it this object, and for app, create an object and give it to us. So we're going to change that now. App assigned to, I'm going to say services dot. Okay. After this, you will have to create another object, and it is called provider. And then it looks like this, service provider. I'm going to call it provider assigned to services dot build service provider, and then this provider is going to give us the object that we need. So I'm going to call get service, and over here I'm going to pass app. Right? So our old code was like this. We were using new keyword in front of the class names. Alright, this class name was something that we will use later on and create object and pass those things along. But then we had very intuitive idea about how to create the app object. We want to give away the object creation to somebody else. And that somebody else in .NET Core requires two things. One is service collection and second is service provider. Using services, we kind of initialized that object. It's okay to have a new keyword, and in these services we told them that which is the interface and which is the concrete implementation. Right? So iReader comes from this, iWriter comes from this, and the app itself comes from this. Because it does not have an interface or any other level of abstraction, app is an abstraction of its own. We can put a single parameter over here. And now if we want to instantiate object, we'll have to create a provider from these services, and then these services using this function is saved inside this thing. Now provider knows how to create all these objects. If we go to the definition of app, the constructor requires two parameters, a reader and a writer. This provider internally has that intelligence of figuring out how to do that. So when we say that, hey, give me a copy of app, it is going to go and build all the objects that are required for creation of the app object successfully. So it's like, hey, I know how to create an app object, but then before that, I have to create a reader and a writer object. So the provider is going to do that for us. And now if we run the application, right, it is saying posting on Facebook, #hello world. Right? Let's go ahead and make a quick modification to the application. I'm going to add the reader and writer. I'm going to delete this part. Let me click the order. Now it knows there are two ways of creating readers, a message reader and Twitter message reader, and a writer and Facebook message writer. Now if I run the application, it is not taking the Facebook and Twitter version, it is taking the plain old console version. That is because you have added another mapping of the service and the implementation of that service. So whatever comes later, it overrides what was defined earlier. And if you want to have some form of control, you can define a name for that service here. This. Okay. But in other implementation, there is a code that you can pass, and then through this you can control which particular implementation you would want to trigger. So Using this get service, you get control over what object or in what form you would want to create those objects. But for now, I hope you understood the concept of dependency injection principle, that you are not going to rely on the new keyword for custom classes. You are going to rely on a framework that is going to do the dependency injection for you. The app constructor is going to get parameters automatically from the service provider. Right? So let's run through this program one more time. We started with the main program. Let me go ahead and put that original line as well. We had console.write line, hello world, right? And then this works. There's nothing wrong with this program. The only problem is that it is violating solid principles. And when you violate solid principles, writing applications that are big, that are flexible, it becomes very difficult. It was violating single responsibility, open close, list cost substitution, interface segregation, and dependency inversion. To fix single responsibility, we went ahead and we added these two classes, the message reader, the message writer, and the app class. Right? Even that did not fix the main function, the program class, because it knew too much about how to create those objects and what those wiring look like. And that was violation of at least open closed and interface segregation principle. I'm so sorry, open closed and the list cost substitution principle. Because when we tried to replace the message reader with Twitter message reader, the app class kind of broke and the main function kind of also broke. We were seeing compilation errors that these types are not compatible. The way we can do that is we can replace the left side, but then we understand from the list cost substitution and the open close that the left side should always be an abstraction. There are three ways we can have an abstraction. We can have a class name itself, which is not inheriting from anything. We can have an interface, or we can have an abstract class. Because of the nature of our application, we chose to go with interfaces. Because there are functionality that we want support, there's a provider and there's a consumer. If we had seen a common noun and proper noun example, we would have gone for the abstract class mechanism, because this is more of an interface application. So we created two interfaces, iReader and iWriter, and we implemented those interfaces in Twitter message reader and Facebook message reader, and also in the console message reader and console message writer. Right? And then we were like, now we can get rid of the new keyword, and .NET Core is offering us that flexibility through service collection. So this service collection, if we just inform for which interface or for which abstraction, which is the implementation that we want to use, .NET Core can give us a provider, and that provider will create the object for us, right? And then this provider will also take care of deeper objects that this particular class is going to require, as long as we have those added to the scope, right? And then through that, if we run our code, the application is going to run just fine. So we have come a long way from console.write line to um, doing app.run. There are multiple interfaces that we added, there are multiple classes that we added, but the output of our application, it did not change at all, right? And that is a form of refactoring. What we have essentially done with this piece of code here is we have refactored it to better fit, better suit the design principles, right? Let me go ahead and comment this code out. Now, the services, it knows how to create the app instance, but an app requires knowledge of reader and writer, and we have not told it how to create those objects. And if we now run the application, notice the exception that we are getting. It's saying unhandled exception number 1. Extension dependency injection service lookup dot call site factory create argument call site. It has failed. And if you read through it, you will figure out that it is because of the dependency chain was not created correctly. It's going to say while attempting to activate console.app console.app class, right? Unable to resolve. So the screen has kind of scrolled out. So it is saying that there is an invalid operation that happened. It is unable to resolve service type of iMessage reader while attempting to activate. right? So it gave only one error. There are at least two errors that happened, but then it gave up on the first error. So let's go ahead and resolve the first error. I'm going to uncomment this, and I'm going to run this application again. Right now it is saying that it is the iMessage writer object that it is not able to create. So it has gone ahead, created the reader object, but it could not create the writer object. And when we uncomment this second line here and run the application again, it is going to work this time because it could create the reader and the writer, which were required for creating the app. It then went ahead and created the app object as well, and it ran the application. The application ran. The rest of the application ran just fine. Makes sense?